In this demonstration, we introduce a pedagogical reference resolution game, serving as a fun and engaging scenario to study repeated interactions with a social robot. And we present the results obtained during a user study conducted with 49 participants. The cooperative game we developed is designed to enhance people's geographic literacy when playing with a robot team partner. The players have the role of the tutor in this scenario. On the iPad, they see the world map with one country highlighted as the target. Their goal is to get the robot to select the same country on the shared screen, which is placed in between the two. The robot thus acts as a learner in the pedagogical game. Any verbal description, including the use of the country's name, is allowed to identify the target. The goal for the human-robot team is to score as many points as possible during the 10 minutes of game interaction.
So it's to the east of India and north of Australia.
Got it.
You got it?
Is it this one?
Yep, that's the one. Good job.
Nice.
So should we take the next one?
Yes. Let's move on.
Alright, you remember where India was?
Yes.
So this country is bordering to India to the west of it.
Is it this one?
Yes, that's the one.
Yay!
Good.
We use the blended robot head fur hat as a robot platform for playing the game. The appearance of the robot can easily be changed by applying a different facial texture, making the robot look human-like, mechanical, or like a morph between the human-like and mechanical version, among others. The robot is teleoperated according to a Wizard of Oz protocol by a researcher trained during 50 online game interactions. Before and after the game, participants engage in a brief social chat with the teleoperated robot.
Hi, I'm Neil. What's your name?
Sophia?
Awesome. Nice to meet you. Well, I guess we get to play a game with each other. That sounds pretty nice, don't you think?
We conducted an experiment in this scenario in which each participant had 3 interaction sessions with the robot, with 3 to 10 days of zero exposure in between. Participants were divided into 3 groups, each playing with either the human-like, mechanical, or morph version of the robot.
No, I'm from France.
Ah, that's just around the corner. What would you recommend to visit in your country? Last time you told me that you go back home not often. Do you miss being in France?
A little. It's nice here, so it's okay.
What do you miss about it?
The food.
Have you been to one of those countries before?
I have to some of them.
Which one?
I've been to Ireland and I've been to Southeast Asia.
I had a lot of fun playing with you. I am very sorry that this is our last meeting. Would you like to meet again in the future?
Yeah, why not?
Nice.
At different times throughout the interaction sessions, participants were asked to report their perception of the robot on multiple dimensions, including their perception of the robot's anthropomorphism, likability, and discomfort with it. We found repeated interactions to have an overall positive effect on people's perception of the robot. Merely interacting with the robot for an extended period increased the robot's perceived anthropomorphism. Participants also liked the robot better the second time they interacted with it, and their perceived discomfort decreased over all 3 sessions they had with the robot. Our findings thus shed new light on the importance of repeated interactions when studying people's perception of social robots.